Graphs of square root functions. Let's look at the most basic, and I'm going to write this as f of x equals square root of x. Same thing as if this was y equals square root of x. So let's look at different points that will work in this equation and see what the graph looks like. So if I think about plugging things in for x, if we think about a negative, like negative square root of 4, we've looked at how that's not a real number. I cannot do that. So I can't plug in any negatives. So we're going to start at 0. That's the first time I can plug in a number and get an answer. So square root of 0 is 0. If x was 1, square root of 1 is 1. 2 I can approximate, but it's not going to be nice, so I'm going to skip 2. Square root of 3 is not a nice number. I'm going to skip to 4. Square root of 4 is 2. 5, 6, 7, 8, 9 is the next time I get a nice perfect square. So square root of 9 is 3. Okay, so my next one, let's kind of jump to the next perfect square, 16. Square root of 16 is 4. Okay, so that is a good amount of points. So if I graph these now, 0, 0, 1, 1, 2, or sorry, 4, 2, 1, 2, 3, 4, 2, 9, 3. It looks like I'm off my graph now. So what this is going to look like, it's a curve that starts going up very gradually as we go. So it's like a parabola sideways, but only part of it. So it's kind of like a half of a sideways parabola. So, so this is what the general square root of x graph looks like. Let's talk about domain and range for a minute too. So the domain of this, remember domain is all the x's. So either if we look at our list of our x's or look at the graph where I have x's, notice I don't have anything. If I kind of think about lines over here, I don't have any x values. I can't plug in negatives and get an answer. So I start at 0 and I want to include it, and that will keep going to infinity. Range is the same thing. If I think about it, I don't get any negative answers. I never got any answers. When I plug in a positive x, I can't output a negative y. So also this is going to be 0 to infinity. Okay, then let's do one more. So the next one we'll do is f of x, or we could say y, equals the square root of x plus 2 plus 3. So this as well, I'm going to have to think a little bit about what x's can I plug in, because I cannot get a negative on the inside here. And I'm even going to show how we can start to think about the domain. This x plus 2, we need this to be greater than or equal to 0. It needs to be greater than 0 because I cannot have a negative. So if I subtract 2, x has to be greater than or equal to negative 2. So that is the first x I can plug in. So if I plug in negative 2 plus 2, and then I have my plus 3 on the outside, square root of 0 is 0, plus 3 is 3. The next one, let's try plugging in negative 1. Negative 1 plus 2, and then plus 3 on the outside. So negative 1 plus 2 is 1, square root of 1 is 1, plus 3 is 4. Now there's probably going to be a couple where I don't get a nice number, because if I plug 0 in for x, 0 plus 2, that doesn't come out nice. 1 plus 2 is 3, that doesn't come out nice. Let's try 2. Square root of 2 plus 2 plus 3. Square root of 4 plus 3 is 2 plus 3, and that is 5. So let's see what we have so far. Negative 2, 3. And then negative 1, 4. 2, 5. And we can assume it's going to have the same kind of curve, just like the last one. So for this one, and we started talking about this domain, The first time I have an x is -2, and then it keeps going to infinity. And then the range, since basically it's kind of like it's a square root, but that +3 on the outside of the radical means that it's shifted up 3. So everything is going up 3. So we start, our first y is 3 to infinity.